The image marks the end of an era. The satellite image of Las Vegas was acquired on May 28, 2024, and it marks one of the last images collected by Landsat 7. Using the shortwave infrared, near-infrared, and red bands, the image offers a vivid depiction of the desert landscape and urban expansion. It was taken after the conclusion of the satellite's science mission and commemorates its 25th anniversary. This final snapshot serves as a meaningful tribute to Landsat 7's long-standing contribution to Earth observation. Hello everyone, and welcome to another episode of Eyes on Earth, a podcast produced at the USGS EROS Center. Our podcast focuses on our ever-changing planet and on the people here at EROS and across the globe who use remote sensing to monitor and study the health of Earth. My name is Tom Adamson. Whenever we talk about Landsat, we mention the myriad ways it helps study land change, monitor crop health and forest health, assess damage after natural disasters, and on and on. And Landsat 7 contributed to all those things over 25 years of operation, sending its data to the Landsat ground station, also known as LGS, here at EROS. Today we're talking with some of the people who kept Landsat 7 flying to make sure it could keep doing its job. Tammy Vajo is a KBR contractor at Goddard Space Flight Center and member of the flight operations team. Tom Cook, also a KBR contractor, is the lead engineer for the flight operations team. And Jim Lacasse is the USGS EROS Landsat Ground Operations Project Manager. How long have you all worked on the flight operations team for Landsat 7? Let's start with Tom.
Yeah, I started on Landsat 7 in the summer of 1994, I believe. So this is about my 30th year anniversary with Landsat 7. So I was on about 5 years before launch.
How about you, Tammy?
I have been on Landsat 7 for 26 years. I came on a year prior to launch, and I've been here ever since.
How about Jim? When did you start with Landsat 7?
Yeah, I have been working with Landsat 7 on and off since the fall of 2003. And that's why I guess I'd like to make the point, too, that I'm the government guy sitting here right now, but there have been a host of people that have been sitting in the role of government oversight of the project.
Okay, you're kind of representing that group for us then.
Exactly. Yeah.
Sounds good. Whenever we consider a spacecraft that operated this long, there are going to be some big numbers. For example, Landsat 7 acquired over 3.3 million scenes, and it went around the Earth over 133,000 times. Here's another interesting number. 117,000 contacts taken. So what does that mean? What is a contact?
A contact is when we talk to the spacecraft. I'll give the example of the LGS ground station. So we schedule times through that ground station that we talk to the spacecraft whenever Landsat flies over, and that's 6 times a day. And we turn on our transmitters and send data down to the LGS ground station, and we send commands back through. So 117,000 plus, because it's been more than that, contacts, that's the number of times that we've actually talked to Landsat 7, sent commands to it and received telemetry from it.
Yeah, we do that through a host of ground sites. Like Tammy said, LGS is one of our prime sites, but we also use sites as far away as McMurdo, Antarctica, Alaska, Australia, Norway, Wallops Island, Virginia, and the NASA communications network that they keep in space. They have comm satellites that a whole fleet of them that we also use for contacts. And the contacts can range anywhere from 5 to 12 to 15 minutes long.
Okay. And this is anything from telemetry data, sending commands to the satellite, and collecting imagery. Does that count too?
Yes, it absolutely counts.
Another interesting stat that we have is that the flight ops team conducted 253 maneuvers on Landsat 7. What type of maneuvers make up the majority of that number?
So yeah, the vast majority of those burns are us counteracting the effects of drag on the orbit. You wouldn't intuitively think that, but even 700 kilometers up, there is a little bit of atmospheric drag, a very, very tiny bit, and it slows us down. And so every once in a while, to maintain our height properly and have our orbital period be the same, we need to counteract that drag and boost the satellite's orbit up just a little bit. Sometimes it's a few meters, sometimes it's tens of meters, but that's the majority of them. There are other burns that we do, maybe a little bit more than a dozen or so, that are done specifically to get out of the way of debris. But the vast majority of the burns that we've done in the past have been drag makeup maneuvers.
So we always have to steer clear of space junk. Maybe that's not the right word to use. Is it orbital debris or space junk?
Technically, it's orbital debris, but it's if it's coming at us, we consider it junk.
Sounds good.
Yeah, it's anything that could be anything from old pieces of launch vehicles to broken up satellites to whatever. It could be small, big. It's a whole host of different things, and we're monitoring that all the time. And we've had, since we started monitoring that in 2010, we've had over 800 instances that we would consider as high interest events, and we would monitor those. And if the probability of a collision with Landsat 7 got to a certain point and the timing was right, we would physically move the satellite, change the orbit just to get out of the way of the debris. That's only happened a dozen or two times since we started. But like I said, we've had over 800 individual events that we've monitored over the years that were potential risks to the satellite.
Did you have any days or moments that really got your heart pumping? Like, wow, that was close. We almost went off the road there.
Yes.
Yeah. An unfortunate number.
Yes, we have.
Oh, no.
There are things that we do that we plan and prepare for. But when something breaks, we get a page in the middle of the night that something isn't as it should be. That's what gets our heart pumping. And I know for me, January of 2024 of this year was one that sticks out in my mind. The orbit has changed enough that the spacecraft no longer went into shadow. And because of that, the spacecraft sat in full sun the whole time. And so things heated up, including the batteries. And the batteries have sat at 2 degrees for 25 years. That's what they're designed to do. And then all of a sudden they shoot up to 10 degrees. And that was nerve-wracking. But we had plans in place. We were prepared. We knew that might happen. And we had things in place to counteract that and bring the battery temperatures back down. And the spacecraft reacted like a champ to everything. It didn't seem to mind anything. It was the team that that got really nervous.
Yeah, Tammy brings up a good point that a lot of the work that we do as the offline engineers, at least, is trying to prepare for things we think might happen. And in this case, we knew the shadow was going away. So those burns that I mentioned earlier that we used to make up for the drag, we've stopped doing those because of a lack of fuel, and we've stopped maintaining the orbit. And the orbit is drifting as it has been for few years now. And as a consequence, like Tammy mentioned, in January, for the first time ever in the quarter century that Landsat 7 had been flying, it did not dip behind the Earth and get a shadow on its orbit. It was in full sun, 24 hours a day, and that was a new paradigm for us. And we had prepared and gotten things together, and we had in our head what might work, and we had procedures ready and all that. But to see it happening, actually happening, and seeing how the spacecraft was reacting was certainly, it's unsettling, because the consistency that we had gotten to know over the previous quarter century was now gone. But the things that really, I agree with Tammy, the things that really get my heart going are, we'll get a page in the middle of the night, 2, 3, 4 in the morning on any given night that something's wrong, and that drive into work, or like firefighters sleeping in your bunk and the bell goes off, and we start heading into work. I remember specifically for myself, I remember a time in I think it was the year rollover in 2001. The spacecraft does not know really what year it is, and it doesn't have a GPS or anything on board. So we have to tell it, we have to be there for every New Year's Eve. We've worked every New Year's Eve for the last 25 years, and we have to sort of shepherd the spacecraft into the new year. And that requires some complex commanding and parameters that are specifically tuned to that specific second for that day, for that year. And that year rollover did not go well, and the spacecraft lost control. And the solar array, which usually rotates to follow the sun, was rotating backwards, and the spacecraft was angry that night, and she let us know about it. I looked up and we were in a contact at the time watching this happen live. And I looked up and we had 3 minutes left in the contact before we were going to lose contact with the spacecraft for at least another hour or two. And we knew that it was out of control and it was losing the sun. And we had collectively as a group, I think there were 5 or 6 of us there that night. We had 180 seconds to figure out what was going down, what was the biggest risk to the spacecraft, and what can we do to save this before it got extremely serious. That gets my heart pumping just thinking about that now. Suffice to say, we figured it out.
The spacecraft didn't know what year it was, and you had to help it sort of turn over the calendar to a new year?
Yeah, that's an operation we have to do every year on New Year's Eve. We have a half-second interval that we have to get several commands in and update new parameters to readjust the baseline year that the satellite's using all of its timing on. And they have to be done just right, and the values have to be just right. And we don't just tell it it's 2024. It's a very modified Julian date, so it's a big number that you have to convert down into binary and get that up on board, patch the flight software. In a way, you're kind of changing the tire on the car while you're going down the road, and you have to do it just right or things go sideways on you. And that year, things went sideways on us, but that's been the only one. Every other one of those operations has been pretty smooth. Although, like I said, we end up working every New Year's Eve. So, but that's the nature of the beast. That's the job we signed up for. We've had people in the control center doing operations every Christmas and Thanksgiving and everybody's birthday, and spacecraft doesn't care about those things. It just needs to be taken care of.
So, Jim, can you talk about if that's an issue with other Landsats?
No, and that's one of the things I was going to say with this mission is it's interesting, something that's been flying this long, and I think you can go back to Landsat 5 and say the same thing. Technology's progressed, the operations concept has progressed, and they learn from every mission to add new features and new autonomy, and you have higher processing powers. One of the development mantras is test as you fly as you test. And so you try to not do anything on orbit that you haven't done on the ground. Well, when a spacecraft's been flying this long, you get into situations where the flight operations team has to reach into their creativity bag and figure out how to do things that it was not designed to do. There are things that with Landsat 7 that you won't see with Landsat 8 and 9 because the design is different now. So my hat's off to the flight operations team. They're working with tools they weren't given in the beginning that they've come up with. So kudos to you guys and recognizing the flight operations team through the years.
I want to go back to one other type of maneuver. There's also an inclination maneuver, and the last one of those happened in February 2017. Can one of you describe real quick what's an inclination maneuver, why that's necessary, and why there were no more of those after February 2017?
Yeah, so the inclination is referring to the inclination of the spacecraft's orbit, and that's the angle between the orbit plane that we operate in and the Earth's equator. During our primary science mission, that was very, very tightly controlled because through a bunch of physics and orbital dynamics, that angle is how we maintain our mean local time. And the mean local time is important because that keeps the sun angle at a very consistent value when we take an image. So when we cross over the equator, we want the sun to be at a certain range of angles over whatever target we're imaging so that it's a consistent lighting conditions from image to image. And so to control that angle and that mean local time, we have to control the orbit's inclination very, very tightly. It was pretty much every year for the first 18 years, really, that we did a slight inclination maintenance maneuver. And we're talking about adjusting that angle by a fraction of a degree. But that makes all the difference in the world. And so in 2017, what happened was we had a requirement that we were going to lower our orbit when the mission was complete, or before we declared the mission complete. We were supposed to lower the orbit 8 kilometers just to get out of the way of the other constellation members that we were flying with at the time. And to do that, you have to reserve a certain amount of fuel to be able to do that operation later on in your life. And so when we got to 2017, the thing about inclination burns is they're very expensive fuel-wise. You have to spend a great amount of fuel to change your inclination just the tiniest bit. And so 2017, it was determined that that was going to be the last time we were going to be able to spend that much fuel to maintain the inclination. And after that point, we were going to let the inclination drift. And so the consequences of that were, so the inclination went up a little bit and then it started drifting down. And in 2018, the inclination was back to where it was around when it was in 2017 when we did our last burn. And then it continued to drift down, which is something we hadn't let it do prior to that. So that mean local time started drifting and it started drifting lower and lower. And we were originally at 10:15 a.m. at that time when we did our 2017 burn. And by the time I think it was 2021, our inclination had drifted enough and the mean local time had drifted down to 9:15, which was the sort of the outer edge, the lower edge of our operational box. And at that time, USGS determined that the sun would, we told them the sun was definitely outside of the 9:45 to 10:15 box. And images were still being used, and USGS made the determination that we should continue imaging, even though the mean local time had drifted beyond that. And we continued imaging up until January of 2024.
So that time that you're talking about, 10:15, that's the time that the spacecraft crosses the equator?
Right. So that's a sort of a theoretical, if you were standing on the equator when we passed overhead, the sun would be around where it is at 10:15 a.m. in the morning.
Okay, gotcha. And that's helping with consistent imagery, which of course is a big deal with Landsat.
Exactly.
Now, the New Year's Eve thing that you have to do, that didn't have anything to do with Y2K, did it?
No, that was a completely separate issue. And because we launched in 99, the developers of our ground system, that was in the forefront of their mind when they were developing the system and the spacecraft as well. Although since the spacecraft doesn't know what year it is, that's actually a bonus at the 2K rollover. But we ended up not having any issues in our control center for that. Early on in the Landsat 7 mission, the scanline corrector, a mechanism inside the ETM Plus sensor, failed. We're going to turn now to Pat Scaramuza and John Christofferson, who were at EROS when that happened. Pat was an image assessment system analyst on the calibration validation team, and John was a principal systems engineer. Can you explain what is a scanline corrector and what does it do?
Landsat 7 is what they call a whisk broom sensor. So there's an actual motor inside the instrument that spins the mirrors back and forth. And they've got bumpers and it just bumps off the side and goes back and forth like a whisk broom.
Okay. Imagine you're in a pickup, sitting on the tail of a pickup with a garden hose. If you're driving along the road at 15 or 20 miles an hour and just going back and forth with that, that's not going to look like parallel lines of water on the road. That's going to look like a zigzag pattern.
Because you're moving forward.
Right. And so what the scanline corrector is what's called a forward motion compensator. It compensates for that forward motion by pushing the deal forward at the beginning and then pulling it back as you go so that you're counteracting the forward motion of the vehicle, of the satellite, and getting parallel scans on the ground, which then make a nice, pretty picture. It's a complicated mechanism. It's a marvel of 70s engineering and 80s engineering when they first put the first ones together for Landsats 4 and 5. They had all functioned wonderfully all these years. And then one morning, actually a user called in and said, this imagery, something's wrong with it, and alerted our crew. And they immediately noticed that that's got to be the scanline corrector that's wrong, because we're now seeing the same thing at the edges of the scan because it's no longer moving that image to compensate for that motion.
You saw some repeated pixels in the scan?
Exactly.
Okay.
So they're repeated at the edges and they're perfect in the middle, and then there's a big gap between each one of them, that zigzag pattern. So that's what we were seeing.
What did you and the other engineers have to do at that point?
So it was a geometry problem. One, we didn't know it was a scanline corrector at first. So Ron Hayes and Jim Story were the geometry people at the time, and they tried to see what the data was doing, why it was happening. Meanwhile, we were looking for the start of the problem because it suddenly appeared. One day the instrument was fine. The next day it wasn't. And we eventually found that scene. I think it's in Alaska, where it's fine at the top of the scan. Then the scans go a little bit crazy. And at the end, it's got the scan line corrector gaps in it.
You're trying to troubleshoot a satellite 438 miles in space where you can't touch it, you can't see it, you can't open it up, grab measurements, you can't whack it upside the head. You can't deal with it. So it's all very painstaking. But we had what is called the engineering model of the original ETM, or the original thematic mapper, built back in the 1980s, late 70s, early 80s, that was a fully functioning thematic mapper sensor, but was meant for testing on the ground. Purely meant to show that, yep, we can build one and this is how it works, and it works. Then we'll go build the space qualified one and get it, up into orbit. But that engineering model ended up being out in EROS's lobby as a display piece, for people to look at. It's all covered in shiny gold foil and looks interesting.
It looks really cool.
Yeah. And I asked, isn't it possible that it could be inside the engineering model? They said, no, it's not there. And that bugged me. So after the meeting, we were in there, I grabbed a digital camera. The digital cameras were still pretty new at the time. We didn't have them on our cell phones and stuff.
This was 2003.
Yeah, right. This is the old days. But I grabbed a digital camera, and I stuck my arm way up inside the telescope and took a picture down there. Oh. Sure enough, there was a scanline corrector in there. And sent the pictures off to California and to NASA. And they're like, well, there it is. And so plans were made to ship a couple of engineers from Santa Barbara out to help crack the ETM Plus open. You have to break it in half almost, and then remove the scanline corrector, send it back to Santa Barbara for analysis. And they had some of the original test equipment that could power it up correctly and so on. And they did further tests, and they couldn't make it break. We have no idea what caused the scanline corrector to fail. Because it's way out in space, we can't go see. We can't open it up and find out. We can surmise or guess, and some of the best guesses are that maybe something broke, or a piece of something got in there and jammed it up, or...
Yeah, that's our best guess. There is a motor there, and there's a shaft. It looks like that shaft broke. And they just could not get the motor to move the mirror at all.
And they tried many different things before they finally, over a period of months, arrived at the formal conclusion that it's broke. Yeah. We kind of knew that months earlier, but like I say, we always hold out hope.
What was the flight ops team doing on 9/11?
For myself, I remember coming into work and listening on the radio as the planes hit the Twin Towers. And when I got into work, I was told to just go home. So I turned around and went right home. There were several members of the team, though, that had to stay. There's critical commanding that needs done every single day. So they got that commanding done, and then they all went home, too. Goddard closed at that point. I think all NASA facilities closed. Even though it was closed, we are essential personnel, so we can get on base, and we needed to. So we continued to come in. Somebody continued to come in every day after 9/11 to take care of the spacecraft, to make sure it was okay, and to do the critical commanding that it needed every day.
Basically, all government facilities closed for non-essential work. So we had the same thing. And I guess one point, Tammy, you were talking about that commanding is necessary, and that included imagery continued as well. And so Landsat 7 did end up capturing, post-impact images that showed smoke coming off of New York.
Yeah, that's the critical work Tammy was talking about. We had to be in the control center to make sure that command load was up, because we knew we were flying ground zero the next day. So we wanted to make sure we got that.
When there's a blizzard or severe weather, someone always has to be on duty anyway, right?
Yes. Like we've mentioned, every single day, every single year, somebody has to be in the control center. So we monitor the weather in the wintertime, and if we see a storm coming, we decide who's going to stay, and we have people that stay overnight in the control center. That way you don't have to worry about coming and going and traveling. And we bring in sleeping bags, and everybody brings in food for them. There are people that stay the night. the January of 2024 incident that I mentioned when we went into full sun. We got a page in the middle of the night, and it was the first snow that we had had in like 800 days. And it was a significant snow, and I'm driving in at like 3 a.m, and you can't see the road, you can't see anything, but we got a page, and we had to get here. And thankfully, everybody did. We all got here safely.
And then that goes to the COVID thing as well, right, Tammy? That's the same thing. There was a global pandemic. The spacecraft doesn't care. And so people have to show up every day and do the necessary operations that have to happen every day. And so there was a core group of people that had to make sure that those operations got completed every single day. And a quarter century when the flight ops team has had somebody in the control center every day. Since launch in this area, we've had multiple hurricanes, several blizzards with multiple feet of snow. We've had an earthquake, tornadoes, the global pandemic, 9/11, all kinds of stuff.
Are there any other memories that any of you would like to share?
There was an incident back in, and I had looked this up, back in 2005, where a U.S. submarine collided with a seamount southeast of Guam. And we got a call actually asking about, what Landsat 7 could see in the water. And we were requested, I don't know if you recall this, Tom and Tammy, but we were requested to take images out just in the open ocean. And that was kind of, we just hadn't done that before. And it worked, and we actually expanded our coastal imaging after that. And, that's just become part, and a big part now. And matter of fact, they're adding bands and stuff to Landsat Next, looking at the water and stuff. So it's kind of interesting how the mission has expanded into areas that weren't thought of back in the day, 25 years ago.
That might be part of the reason that there's something like 750 images per day now taken from each Landsat 8 and 9, and Landsat Next will have a huge load of data too, because we're expanding to coastal areas.
One of my specific core memories of the past 30 years is launch day for Landsat 7. I was the flight controller there that day, and I was on for the launch shift. And my daughter had been born that week, so it was a very, very busy week for me. No sleep at all. It was a very nervous time, not just because you have this satellite that we had all worked on for a few years prior to that already, and we'd gone up to Valley Forge where it was built and helped them test it in the thermal vac chamber and done all, you've invested years of your life already at that point in this mission. And now you see it sitting on top of this rocket. And it was a very, very tense day. But on top of all of that, we were racing to fill a gap that was left by the launch failure of Landsat 6. And there was a lot of consternation in the community that there was going to be a gap in Landsat data. And that's, there's a string of unbroken data going into the archive all the way back to Landsat 1. And so there was a lot of pressure on this going well and working properly. And I remember standing there behind the controllers, getting ready for launch. And of course, we're not in control at that point. You're on the launch vehicle and the countdown's going down. And if I'm not mistaken, I think our first contact was blown. We didn't get that. So that was a little bit nerve-wracking. And the room is full of people from the builder, the team, everybody was in there and just trying to handle the whole room and keep everybody quiet and not to get too excited because, there's just a lot of emotions going on. And of course, I was operating on zero sleep for the week because of my newborn, but that was 25, 26 years ago now.
Tammy, any other memories that you would like to share?
There's 25 years worth of memories in my in my head. So launch day was a big memory for me too, and I'll put a slightly different spin on it. Tom's right. We had the spacecraft builder there and managers and NASA and everybody was there, and it was tense, but it went well. And I happened to be wearing an orange Landsat shirt that day. And because launch went well, we attributed that to the fact of I was wearing an orange shirt. So that's called the lucky shirt. So now everybody on the team has an orange Landsat shirt. And whenever we do any unusual commanding or have an anomaly, we all show up wearing an orange shirt for luck. And that was something that happened on launch day.
I'm glad to know that engineers aren't superstitious or anything.
Every little bit helps.
Yeah.
We're not saying that's why things work, but we're not willing to chance it either.
Jim, I'll give you a chance for any other memories.
I just think of the legacy of Landsat 7, of how many people it's been their career, or how many people that it's been, stepping stone in their career. And that includes, not only the folks sitting here that we represent, but also the internationals, because there's the international aspect to this, and the data that's been downlinked. And it was a little bit different going back, because with the smaller recorder, data had to be downlinked to the ground. And now we spent years getting that data back through another project. But again, it's just a memory of the breadth of this program, the people that have participated in it, and the benefit that it's done over these 25 years for the entire world.
We were the first program that's when USGS decided to give the data away for free, right? And I think the user community expanded exponentially.
Yeah, I was going to note that too, that it was Landsat 7 when we changed over to no charge, and we saw the rapid expansion of the use of the data.
If you had to summarize Landsat 7's mission and legacy in, say, 30 seconds.
From the flight ops team perspective, most of us have been around since launch. And because of that, we have established relationships with so many other groups and companies and organizations around the world and around the country. And that makes operating Landsat 7 easier. Not easy, but easier, because if there's a problem or a question or something, we know who to go to fix the problem or to troubleshoot and answer a question. And because of that, we have a great mission, and we are a part of that. We keep the spacecraft healthy and producing as much science as it possibly can, and downlinking all of those images into the archive. And that's something that the team is extremely proud of.
Yeah, that's a tough one for me, because there's just so much. I'll squeeze the last 30 years into 30 seconds, but there's a local legacy here. That's the teamwork that we've had, and the collaboration that it takes to keep this thing flying and keep it healthy and out of harm's way, and taking care of it and preparing it. So many of us have been here for decades, that we've seen, we've been around together. It's kind of a different, like a work family, really. And we've seen each other get married, have kids, a couple of divorces in there, some serious medical issues. Like, we've just shared so much amongst ourselves as a group. And we work so well together as a team. And then there's the global legacy of the Landsat 7 or the Landsat project in general, and how proud we are to be a part of that, and to be a bridge between the Landsats before us and the Landsats that come after us. It's a privilege to have worked on. It really is.
Thank you to Pat Scaramuza and John Christofferson for sharing your insights on the scanline corrector situation, and to Tammy Vajo, Tom Cook, and Jim Lacasse for sharing your thoughts and experiences about your time on the Landsat 7 flight operations team. Check out our social media accounts to watch for all future episodes. You can also subscribe to us on Apple and YouTube podcasts.
This podcast
is a product of the U.S. Geological Survey, Department of Interior.
I have to add a quick did you know fact. Landsat 7 is an artist.
Yep.
Landsat 7 imagery was the inspiration for the first Earth as Art collection.
Yeah, I remember when they started that.
They're beautiful images.
Yeah.
And you can hear more about that on Eyes on Earth episode 97.